Hello everyone. In today's stream we're going to be continuing our package resolve port to the Playdate as we venture forth into drawing the rest of the owl. Hopefully today we'll just do some more box magic, maybe get some other things going, collisions and rolling backgrounds. Who knows? This is the part of the script where we just kind of throw it out and just be like, see what happens. How's everyone doing today? Oh, it looks kind of empty right now. Well, I suppose that's fine. Oh, we got one person. Hello to that one person. I suppose let's kind of take a look to see what I have done since the last time, which actually was surprisingly quite a lot. Oh, hey, it's on. So, to kind of briefly go over what we've accomplished, last week we were trying to get some stuff with the boxes done, so you can actually get the boxes onto the screen and put them in randomized positions. And we discovered that for some reason this was broken, and our tests were saying, "Hey, you're not doing it right." And so last night I spent some time trying to figure out why that was, and thankfully there was somebody in the Playdate Squad Discord server that pointed out just how much of an idiot I was. It turned out that we were just kind of doing this wrong. And it turned out that I actually did know what I was doing with arrays in C. It's just our initialization to try and make an empty array was wrong, and thus we went down the wrong rabbit hole. So now it works. We now have a standard array of boxes rather than a pointer array, which definitely makes things a lot easier. And now things kind of work as intended. And I took this a step further. As you can kind of see here, I have this method called shift box. So if I were to run the game now, once the simulator loads, it's taking a moment to build, unusually. Okay, there we go. You can see here, we now have a bunch of A's on the screen that are going up. Woo! That's the exciting stuff. So I did kind of pursue this a little bit further just to make it easier for us to just kind of dig into the more gamey parts. Oh, you know what? I just realized. There we go. Now you should be able to see the A's properly there. Don't even worry about the code that I wrote. A's! We'll eventually get those to be real boxes at some point. But for now, we're just going to try and see if we can get a collector up or get something to collect the count and whatnot and see how far we can kind of take that. So if we were to take a brief look at our discovery tree, kind of going down the line, core gameplay loop, collecting boxes, constantly move them up the screen. You saw that we've done that. So now we're at the stage of erasing them when they're colliding, as well as kind of incrementing the count here. So let's kind of get into that then. So let's see here. So here's where we kind of call the code to actually get rid of that to-do comment that was from last night. I forgot to remove that. So this is where we actually draw the characters onto the screen. So probably at some point in here, probably after the drawing the updates here, that's where we're going to start to need to do some things. So, right, because this is our real-time updates. So I will just call this section the draw section. Draw to screen. And then here will be where our actions go. Just to make that a little bit clearer. At some point I will want to revisit this cranking thing, because I would also like to show the little crank prompt that says, use the crank. But we haven't gotten to that part yet, so we'll see. Now, so we're probably going to want to do something in here to check the whether we're colliding with a box. We could also try to do that in here too, possibly, since we are updating the position afterwards. Yeah, I suppose we could try doing that. Boxes. So we should be able to... Let's check and see if the API provides anything for this in terms of collisions. Graphics, Lua sprites, collisions. Set collision response function, move with collisions. Oh, this might be for just traditional query sprites interact. Returns an array of all sprites that intersect the width and height. Len is to the size of the array. For now, maybe we could just do this a little bit more simply and just kind of do a distance check between the points, right? So like between the player's point and the actual point of the box, because I think that's what I actually did when we... Well, in the Godot version, we actually used an area and just checked when it was in the area, but we don't have areas here. So we're going to have to do a little bit more for that. So I think we can actually put this here in our vector stuff. So first let me write out the prototype. So let's do a float vec to f distance, vec to f a, vec to f b. Yes, that is what we're going to want, and let's quickly write a unit test for this, as I want to make sure that we have that all set up as well. Right, so these are the vector tests. Mark. Here's where our box tests are going to go. And at some point we'll probably need to write a is box being collided at some point. So let's create ourselves a quick unit test. Test vec to f distance const m unit parameter params void star data. Those don't actually get used because we do all our setup inside of the unit test. For now, I'm just going to make this return a failure. And then we're just going to come down here and we're going to update this inside of here as well. At some point, I really should just make a macro to simplify some of this a little bit. Didn't think of that, though. Vec to f distance. Test vec to f distance. No setup, no teardown. Unit test option none. And no parameters to specify that. You're slightly misaligned there. I'm sure at some point we'll figure out a macro. So let's verify that our unit test will run and that it... Ooh! Did I boo-boo? We boo-booed. That would be why. Test Charlotte vec to f distance fail. Okay, so we are failing as expected. That is the point of us writing the test this way. So for anyone familiar with what we're doing here, we're trying to follow a somewhat test-driven development approach. In this case, we're using what's known as the red-green refactor method. So first we write a failing test, and then we're going to update our code such that the test will pass. And then after that, we will refactor our implementation a little bit to make it cleaner, but also still have the test pass. This way we can focus more on making sure that the functionality works as expected, so we know that it works against the certain cases that we've defined. And I generally prefer this approach when it comes to a lot of these things, such as these library functions like the distance between 2 points. Because otherwise things could get ugly very quickly, and we'll encounter tons of bugs like we did before, right? When I was trying to do this test box fill, when we discovered that I was just doing a whole bunch of things wrong. Right, if we didn't have those tests to tell us that it wasn't working correctly, we wouldn't know until after the fact and later into production. So that's why we're writing all these tests out first before jumping into the actual code itself. So anyway, let's keep setting this up. So vec2f1 is 1, 1, vec2f0, 0, 0. And we could probably make those into here, huh? Const vec2f, vec2f0 is 0, 0, like that, and then const vec2f, vec2f1 is the same thing here, 1, 1. And I think that means for this one, oh, well, we do something a little bit different there. So we actually don't need this part anymore. We're going to change this to be munit OK, because that means that the test will have passed at this point. So let's now write our test that says munit assert, so first we need to declare our distance is vec2f distance between, is it 1 and 0 or 0 and 1? One of the two. So we'll do vec2f1, vec2f0. Did I put an actual 0 instead of... Don't mind if I do. Okay. Assert float distance equals 1. Worst case scenario, we may need to call the isApproximated function that I did write a while back, just to make sure that that works correctly. Vec2f distance undefined symbols referenced from, why is this? Because we didn't define an actual implementation. Okay. Part of the red-green refactor approach here, right? For now, I'm just going to have this return 0. I also need to have this import vector as well. Include vector.h. Ooh. Duplicate symbol in boxes, vector, movement. Didn't really like that. Okay. What if we did this as a define then? Well, it's not important. We can figure that out later. That was just to make our lives a little bit easier, but I am fine with doing it this way. Vec2 F1 is 1, 1. Vec2 F0 is 0, 0. Wow, the spacing on that is really weird. 1 and 0. Okay, here we go. Assertion failed. Distance is not equal to 1. Task failed successfully. So, let's actually go implement the distance function. I don't think we'll be using Manhattan for this, so let's just get the standard distance function here. Which I have forgotten off the top of my head, but I remember there's some square roots involved. Shush, Google. I do not want to be signed in. Oh, you know what? I need to say distance between 2 points. Yeah, that's what it is. Okay. I'm just gonna copy this real quick. Put that right there. We're also probably going to need to include math.h as well. X2 minus x1 squared. Okay, so we're going to say float diff x is b dot x minus a dot x. Okay? And float diff y is b dot y minus a dot y. Okay, that sets us up. So we need to square both of them. Do we have pow? Yes, we do. We do have pow f. So we'll do that as well. Squared x is pow f of diff x 2 float squared y is pow f diff y by 2 as well. Okay. So now we just need to add those together and then square root it. So I think we could just make that as simple as square rooting? Yes, square root f of diff, no, not diff, squared x plus squared y. Wow, words. Let's run our unit tests again. 1.414214, yada 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 yada. Okay, I assume it probably has to do something with floating points here, so we will probably have to do an is-approx. Okay, right? Probably. You can see what each of these values looks like. Printf sx f sy f. Let's put a new line character before and after, just so we have a cleaner representation here. Squared x squared y. So you get 1 and 1. Okay. Interesting. Is it as a result of square rooting it? Let? What is let? I'm going to make this say return root. Can I move this line down? Yes, we can. And root, or I guess we'll say distance in this case because we already know that's going to be the result of the formula. Root. Okay, so it's when this is being square rooted that we get this random amount here. There may be something that I'm not aware of in here that's doing that. So I think this is just floating point being floating point. So I think we can disregard it. I'm not sure. I don't think it would necessarily be a good idea to do that. Though we can simplify some of this a little bit. Yeah, okay. Or is it because this is on a diagonal? Ah! No, okay. Okay, it's because it's on a diagonal. Right, okay. That makes a lot more sense. So, the test case was reflecting wrong there. Okay. So let's write another one again. Just to kind of show that. So 2 is 2 vec 2f. Well, we don't need to declare 0 again. We can just reuse that. Float farther is vec 2f distance between 2 and 0. Unit assert. I'm just going to use an assert true here. Okay, hold on. Let's actually do the math on this one real quick. There we go. Okay, so x2 is going to be 0 minus x1, which is 2. y2 is going to be 0. y1 is going to be 2 as well. Okay, so 0 minus 2, that becomes negative 2. That also becomes negative 2. Negative 2 squared. Yeah, that should just be 4. Right? Let me check that. Negative 4. Are you sure we're doing that right? I don't trust that. I do not trust that. Encapsulate. Okay, that's what I thought. That's what I thought. Don't play tricks with me, calculator. Don't play tricks with me. Resolves to 8. So what is the square root of 8? That value. I probably could have just done the square root of 8 thing. Do we have math in here? Yes, we do. Don't be stupid. It's QRT. f of 8. We'll do 3 decimal places. See how that goes. Nice. Nice. Okay, that is working as expected. Not much we need to refactor with this as well either. So this is completely fine. Nice. Okay. That works. Cool. So let me just commit this up real quick before I forget. Also run the formatter to let the formatter format. I really need to find some extension that allows me to do a format on save instead of me running it manually, but what are you gonna do? Yeah, okay. We are looking good so far. So let's go ahead and do a little commit here. Add vec2f distance. This will be used to check the distance between the player and the box in a somewhat naive approach. Going to format that. Excellent, excellent. Check our source code here. Yep, you can see it right there. Looking good. Looking good. And this is usually attached to every video, or every stream now because of the way that I have the template set up. But I'll drop it in the chat as well. This is the actual source code. So it is more or less open source software. For anyone that wants to peruse and take a look, see how it works, this is how we do it. I will also do another solid here. I think we have the... Do we have the Playdate squad also included? Yes, we do. Yes, we do. If Playdate sounds very fun and interesting to you, highly recommend checking out the Playdate squad Discord. I do not run it, but it is a fun place to be. You will see there almost every Friday night. Just chatting with other Playdate folks, whether it's playing games or talking more about game dev, that sort of thing. Sooner or later, we should be having the Playdate Awards coming up, so that'll be very interesting to see turn out. Anyways, that's an aside. Small little promotional material there. Let's get back to this. Okay, so we know that, at least for now anyway, that our distance function is working correctly. So let's see if we can use this to our advantage and do stuff. I think what we'll also do as well is render some sort of like, here's how many boxes you've collected. Boxes collected is 0. So let's add that as well. And see, this is the one sucky thing about microunit. Is as good as it is a unit testing framework for just general C, I wish there were some sort of like Playdate specific version that really hooked into the Playdate API so we can verify that things are drawing to the screen correctly instead of manually writing it, but what are you gonna do? Ooh, that was a little sloppy. So anyway, let's work with this here. Graphics, draw text. Wow, apparently I do not know how to char star. Right, because we're going to want our counter is boxes collected. Do we have a string format? Could have swore we had something, maybe even in the Playdate API for this. Let me look. Let me look. Utility functions. Realloc. Error. Log to console. Add menu item. We're not doing things with the menu, so... Oh, miscellaneous. Okay, so we need to do... I guess we need to do that. So PD... What was the method again? PD system format string char ret const char format allocates a buffer ret and formats a string. Okay, so I guess we pass counter here, followed by the format boxes collected I, followed by boxes collected, I think, and then we can use that counter here, and then grab the strlen of counter, k ASCII encoding, and then the X position we know is going to be 0. I forgot what the default size for this is. I think it's like, what, 14 point? Yeah, 14 point. So we're probably going to want to do screenbounds.y minus 14. We're going to have to revisit this part. I don't trust that. I do not trust this one bit. We'll see. Show report. Function declaration isn't a prototype. What? Undefined reference to format string. Is that not what it's called? PD system format string. Oh. We didn't dereference properly. Okay, yeah, so we're going to need to shift it a little bit, but that's fine. So we'll do 8. Right, because that'll be the padding or offset there. Great. So we have a visual indicator. So that'll help. I will probably need to do something about that. Since that does return an integer value. I don't know what the integer value is for yet. We will keep that in mind. So we will leave that be. Meanwhile, let's figure out our logic for this. So we probably want to do the collision check afterwards. Yeah, we probably want to do that. Okay, fine. Let's say distance to player is the vec2f distance between the player. So, do we know where the player's position is? Like, are we keeping track of that in here? Sprite position is translated movement. Public. Why is it an int? Oh no, it's a vec2f. We're fine. Okay. Sprite position. And our boxes at this specific point in time. Now, if the distance to the player is less than, we'll say 64, then what we're going to do is we're going to set the boxes of eyes x to be minus Charlie height, and then we're going to do boxes collected plus plus to say that we want to increase. Oh! Okay, the distance here is a little too aggressive, like it's a little far. But we are collecting boxes. Okay. We have a prototype, ladies and gentlemen. This is really cool. So let's lower the threshold here. Maybe 32 would be a good option. Yeah, okay, that's starting to feel a lot more like it. Yeah, look at that. We are getting somewhere, ladies and gentlemen. Now, I want to take this a step further. Because while it's nice to play with it with just the simulator, we got the physical thing, right? So, let's hook it up. Meanwhile, I'm going to switch this to large real quick. Grab out my trusty USB cable. Got a lot of these USB-C cables now that like almost everything is USB-C. Fun. Some work, some don't. Hello, it's awesome. Yes, it is awesome. We are collecting boxes, which means that a good portion of the game's already done. We just need to change the A's to something not A, like an actual box. That requires me to do some artwork, though. From Indonesia. Nice to meet you. Oh, greetings. Welcome to the stream. Good to see some representation from other parts of the world here. Okay. So I think, yes. Let's just yoink that. Go to the Playdate, Games, User. Just going to drop it in there. And then we're going to eject the disk. I'm going to use the mirror app here. So hopefully you should be able to see my screen here. Can I speak? Sadly, no. No. I'm learning a little bit of German, and I did speak a little bit of French because I learned that in college, but that's as far as that goes. I guess Japanese as well, but that was like a long time ago back in high school. So. Anyways, we got our crank. Yeah, that feels really good. Ooh. Ooh. Okay. I mean, we're going to have to limit the vertical edges here a little bit, but because I'm noticing like it does occasionally try to put itself off, and also I am noticing the mirror is having a hard time keeping up right now. But this is looking good. Okay, yeah. Ooh. I'm just gonna hold the crank like this, but yeah. Ooh. That feels solid. Now, Oh, right. That's not the simulator, that's the actual device. Okay. It could also be because I'm streaming, so it's freaking out that way. Um, okay, that actually feels really good. So what I'm going to do is I'm going to run this in the simulator as well, and I want to check on the memory console here. Because I want to see how memory intensive this is. I mean, it shouldn't be because we spent so much time optimizing a lot of things here. Um, like figuring out like that we were drawing the sprite one too many times. Okay, yeah, so the heap is starting to go up a little bit. I'm trying to figure out why that might be. Let me take a look at the list here. I mean, that could be just from the counter being incremented. But we shouldn't be trying to... Oh, you know what? I think I know what it is. Or at least a good portion of it. Right, because we have the boxes collected string being generated inside of the actual thing. It's creating a new string every time, and I think that's not being freed from memory. So let's go ahead and modify this a little bit to include that counter message in here as well. So char star counter message, like that. So then we can change our code here to then be counter message. And then do the same thing here as well. Oh, thank you, Aton. I almost forgot. Okay, so let's see how that fares when we do that instead. Okay, so far we're being steady. We are being steady about it. Okay, we're starting to increase again. I think there's being a redundant copy around here somewhere. So we're gonna have to check and see where that's coming from. Could be a multitude of things, but as far as I'm concerned, this doesn't seem to be too far off. Like, it's gonna be taking quite a while before we end up reaching like the 16 megabyte limit that the Playdate has. And not to mention that, in addition to this, right, you're only going to be getting a certain amount of time to complete each level. So maybe this isn't actually a problem, and us trying to optimize too early is going to give us some headache. But suffice to say, this is actually looking really good. We could also try to limit the expressions here, though I don't think that's actually necessary. Suffice to say, though, this is actually looking really, really good. So let me commit these changes. Sorry, I must have been hearing some children outside or something. Just run our formatter real quick. Yeah, okay. So here we will collect a box and update counter. Yeah, this is looking really good. So let's go back to the discovery tree and mark that as done. So erase when colliding. Done. So pretty much the bulk of collecting boxes is done at this point. Now, let's take a look at some of this other stuff in here that we have. We got the rolling background, timer, obstacles. I think what I'll do is I'll try to optimize or refine the generation code that generates the words that generates the border there, right? Because as I had noticed when we were playing a little bit, that sometimes the boxes would appear right on the edge of the screen. So we're definitely going to need to change that a little bit as well. So probably in both fill and shift, we will need to specify offsets on each side. Or just specify a different type entirely. That I could do too. Yeah, I think we could start with that as well. No, I'm not sure if I want to do that right inside of the boxes, or if we want to do that in another file like insets or something. I think for now we'll keep it in boxes, and if it becomes necessary to move it out, then we'll move it out. So let me revisit the C, or not the C, the vector here. So that way we can do this. Def struct inset so then we'll say int top, int left, int right, int bottom. So we'll take care of that there. So we're going to need to add that as part of the insets, or as part of the fill boxes and the shift box. So we're gonna have to also update the unit test to support that. The easiest way I think we would be able to do that would be to just set the insets to be 0. Insets like that. And then we go back to insets. And then if we were to go back to our test, where we actually do things with the box fill, which is right here. And then we're just going to say insets is, we're just going to zero them all out here, right? We'll need to do the same thing for shift, but for now, let's just assume that everything fails. Why is that? Insets. That's a little interesting. Is it because we forgot to do something? Ah, yes. We need to refer to ourselves because the header file has the type information. Okay, so the unit tests are fine right now. So I'm going to duplicate this method. I'm going to call with insets. So we'll keep our top and bottom insets fine there. But we will have left and right insets of 32. So then that means that this value must be less than or equal to 400 minus 32. That is 368. 368. And the x value must be greater than or equal to 32. like that. So let's grab our fill option, do this, fill with insets, like this, run our unit tests, and our test fails as expected. Okay, very good, very good. So let's go back to our boxes method here. So we need to change this part. Bounds.x, right, because that's like the very edge, minus insets dot right, and then if expose is less than our insets dot left. I forgot to encapsulate the entire condition. Our x position becomes insets dot left. Oh. Whoa. Yeah, okay. Okay, yep. Now the unit test pass. Cool. So the next thing then is we should probably also update this to include the top and bottom insets as well. So we'll do 16. I think for now we'll leave that because I don't think we'll need the top ones. But very good that we have that option available to us. And I think what we will do as well to preserve the old iteration here is we'll go back. And do that. Do that. And then we'll come back to boxes.c. We'll re-implement that part. So then we just call fill boxes, boxes quantity bounds, and then we just need to set our insets. Inset 0 is 0, 0, 0, and 0. And we will just do that. Oh! You do not like this. Too many arguments to function call. Expected 3, but we have 4. Void fill boxes. Oh. Never mind. We can't overload. Fine with me. So that means we will have to change the code where it says fill boxes here. Yeah, okay, so we'll say define x inset to be 32. Here, let's go look for that call that fills the boxes, right? Yeah, we just want the inset of our, I'll just say walls 0, x inset 0, like this, and then we will say walls like that. We need to run the simulator. Now, of course, this means the newly generated ones aren't going to be on the sides yet, because we didn't include that in our methods, or in the shifting part. But that's fine. Also, what I'm going to do is that's going to remain consistent throughout the entire thing. So let's declare that as such up there. Which should save us some time later when we have to later do things. But yeah, this looks fine. Okay. Though we do have 3 minutes. Do we want to speed this run out and try to... Yeah, why not? Why not? Let's go. So we have test box shift with insets. And then we're just going to say inset 0 is this. 0, 0, 0, 0. Again. 0. And 0. And then we're going to set our inset here as well. Insets is 0, 32, 32, 0. Right? Insets, and then we just need to take the shift 1 again, like this, with insets, and then we just need to go back to our boxes H to include that as well. Insets, and then we just do the same thing here as well. If we were to run our unit tests, everything says okay for now, but that's because we didn't update the test for the insets here. So m unit assert float 39, okay. Right, so here is where we make that actual check. M unit assert float simple shift. Actually, this should be referring to new assignment, as I am noticing here. New assignment. Oh, because we're redoing it. Okay. That's a faulty test there. I will have to refactor that. 32.0, and then we'll just do the same thing this way. And I think we determined this was 368. I think the problem is this is a little bit too random. That's fine. Let's go back to the box. Let's see. Transform.x is minus insets, inset dot insets dot right if transformed dot x is less than insets dot left, and we do the same thing again. Transform dot x is insets dot left. And that should save us the trouble. Yes. I probably will want to change the code here to be a little bit... Yeah. If transformed.y is greater than or equal to the threshold, then let's simply return the transformed here. Therefore, breaking this condition out, threshold. Ah, forgot an H. Okay, that works. That works. So now we can use the shift box and pass in the walls. So that means that they should no longer be any more than 32 pixels from the left, and no more than 32 pixels from the right. Yeah, look at that. This is starting to look like a proper game now. Excellent. Excellent. Okay. So let's format the files. Format the files. Always format the files. Okay. Use insets to draw boxes inside. This way they don't appear at the edges of the Playdate's screen, and make it a little easier to collect. This also ensures that the background won't collide with the box visually. Okay, we will format the commit message here. Excellent! Whoo! Hoo hoo hoo! We are getting somewhere. So I think the next thing we can probably tackle is either the timer or the rolling background. Maybe the timer, just so that way we can actually test things there, but yeah, this is looking pretty darn good. We are doing very well. So yeah, I think that is where we're going to call it for today. Thanks to those that have joined the stream today. Looking forward to see you next week as we continue this project and flesh this out into a full game. Alrighty, take care everyone.